Hi, I'm Marcus Hutchins. I'm a tech service and business development manager at allnex. Today I'm here to discuss UV-Curable Resin solutions for automotive. Before we begin, I'd like to give special acknowledgments to Kevin Polsmans and Yan Lee. The concept for formulating a UV and a conventional coating is the same. Both use oligomeric and monomeric materials that can be described as a polyester, a urethane, epoxy, or an acrylic. Materials are chosen based on their structure-property relationships. Oligomeric materials make up the bulk of the performance needs. Their principles behind functionality remain the same. The higher the functionality, the higher the hardness, the lower the functionality, the more flexible system you will have. Lower the molecular weight, the lower the viscosity. The additive package concept remains the same for both chemistries. The difference is cure. Conventional systems can undergo several curing mechanisms, such as oxidative or polyaddition reaction. This reaction takes minutes, hours, days, and sometimes even weeks before it's fully mature, and that includes the maturity of its performance properties as well. For UV, it typically undergoes only a polyaddition reaction. This reaction is lightning fast. Once the photoinitiator sees a light at a particular wavelength, a radical is generated that reacts with the activated groups in fractions of seconds. In a blink of an eye, you go from a liquid state to a solid state, having full performance properties. Conventional coatings have served the automotive market well for many decades, offering full cure of a variety of geometric shapes, excellent adhesion to a multitude of substrates, and outstanding durability. The process for curing conventional chemistries comes at a cost. Unlike UV, conventional coatings do not cure in a blink of an eye. They require a large carbon footprint for drying and curing. That process typically requires a thermal step greater than 100 degrees C and for a minimum of 15 minutes. And that's just to develop the green strength. Such temperatures limit the number of substrates available to designers. UV has its issues as well, such as curing 3D shapes. If the coating doesn't see light, it does not cure. Adhesion can be problematic as UV coatings only adhere through hydrogen bonding. And then one of the benefits of UV, the high crossing density, can also be a curse, as it can create too much crossing density and lead to brittleness in the coating. The good news is innovation. Innovation has started to address many of the shortcomings of UV, allowing formulators, finishers, and OEMs to enjoy the benefits of UV, such as high throughput, rapid cure, the use of more heat-sensitive substrates, and outstanding chemical and abrasion resistance that will meet some of the more aggressive and harsher standards being established today. UV is not new to automotive. In the mid-80s, UV was introduced into the automotive world as a hard coat for headlamps. Allnex EBECRYL line was there, providing key raw materials to formulate the UV curable hard coat. Over the years, Allnex has created a diverse and innovative product line that can be used in automotive applications such as headlamps, paint protection film, and vehicle refinish. In the preceding slides, we will take a high-level look into some of these key products. Automotive Exterior. Automotive exterior applications are the most challenging applications for UV because of the stigma of poor weathability. That stigma is well earned because initial UV hardcoats for headlamps struggle to pass 5 years of outdoor durability. A positive step forward is the development of EBECRYL's 4680, 4685. They offer a unique combination of hardness, weathability, and ductility, making them ideal choices for today's automotive headlamp applications. They offer similar hardness as traditional UV curable hardcoats, but an 8 to 10 time improvement in weathability. Will these materials weather as well as conventional clear coats, Probably not, but only time will tell. But what we do know, EBECRYL 4680 and EBECRYL 4685 closes the performance gaps between conventional chemistries and UV. Another step forward in closing the gap is the developments of EBECRYL's 8606, 8314, and 8315. UV coatings are widely considered thermoset in nature due to their high crossing density. EBECRYL's 8606, 8314, and 8315 offers a combination of thermoset and thermoplastic behavior. They are tetra and trifunctional urethanes that offer between 70 and 115% elongation, making them ideal for paint protection film applications. The thermoplastic behavior allows these materials the application dexterity to be applied to the entire car, including being stretched around automotive side mirrors, and the thermoset behavior to meet many scratch, abrasion, and chemical resistance standards for paint protection film markets. Additionally, the combination of the thermoset and thermoplastic behavior makes EBECRYL's 8606, 8314, and 8315 ideal for automotive interior applications as well, especially those requiring thermoforming. Speaking of needs, sustainability is an important need for all of us. Almost every R&D has been challenged with improving sustainability in their new developments. For allnex, RX20008 is one of those solutions. It targets high solid content spray applications. RX20008 offers higher hardness than EBECRYL's 4680 and 4685 and weathability that is on par, if not better, than those materials at half the viscosity, even without dilutions. The low viscosity makes RX20008 ideal for high solids applications of 80% or greater. The hardness and weathability makes this material ideal for headlamp and LiDAR applications. Automotive Electronics. As transportation becomes more autonomous for not only driving, but for safety, the demand for electronics will continue to grow, thus requiring improvements in throughput efficiencies while maintaining board reliability and performance. allnex offers a series of products for printed circuit boards that offer a combination of conventional and UV chemistry in the same backbone. We refer to these materials as NCO acrylates. Please note that NCO acrylates do not carry the same health rating as monomeric isocyanates. These NCO acrylates offer the rapid cure response to improve throughput, the crossing density to protect the board, and the NCO functionality to react with the moisture that can be found in the coating or at the surface of the board air interface prior to being coated. Two products in this series, EBECRYL 4510 and EBECRYL 4397, offer unique performance attributes over a wide range of temperatures while maintaining excellent dielectric properties. Automotive Interior. Conventional coatings have been a mainstay in automotive interior applications for many decades. But with the growth of more temperature-sensitive plastics and harsher OEM standards has left a unique challenge for conventional coatings going forward. For UV coatings, it's ready to meet these challenges today, offering the formulation latitude and the performance to meet harsher OEM standards. Such as for sustainability. UCECOAT 7230 is a water-based UV. After water evaporation, it offers hard coat performance that is on par with many high solids, 100% solids UV-Curable hard coat systems that are able to meet the harsher OEM standards. Then you have products that offer a lot of formulation dexterity, such as IIR 1033. This product can be formulated into a high gloss system. It can be formulated into a dead matte system, And then it can be formulated into a black UV hard coat, which can be applied to black plastics as a hard coat for those materials. Then you have products such as EBECRYL 8896 and 8894. These products can be formulated into a number of haptic fields, meaning a number of different standards for haptic for OEMs, plus offer excellent resistance to DEET, sun cream, and sun lotion resistance, even at elevated temperatures over time. Then you have products such as EBECRYL 4900 and 4950. These materials are the best of both worlds, meaning they marry conventional and UV chemistries into the same backbone. Yes, this is a 2K system, but it's the best of both worlds. If you do the thermal part first, you get a material that is tag-free and storage stable. And more importantly, it can be stretched to over 300% elongation, allowing it to be molded into a number of different designs and shapes. After UV, this material goes from a thermoplastic to a thermal set material in a blink of an eye, offering the performance to meet the tougher OEM standards. Automotive seating. With the continued growth of ride sharing and the anticipated introduction of ride sharing using autonomous vehicles, OEMs are concerned with the spread of diseases from one user to the next. This has prompted many OEMs to switch from cloth to synthetic fibers. To coat these fibers, UV coatings could be an upgrade over conventional systems, offering an improvement in scratch, abrasion, and chemical resistance while maintaining outstanding flexibility and stain resistance. Looking at the pictures of the denim test, IRR is a water-based solution that was coated on PVC substrate. It was formulated as a high gloss system and as a matte finish. And as you can see, the UV-Curable solution offers excellent stain resistance in both the matte and the high gloss finishes. Additionally, IRR 912 survives 300,000 flex tests on the Bally test. Automotive Refinish. The concept of automotive refinish and UV has been around for about a decade. However, the progress has been limited due to the lack of mobile curing equipment. Things have changed. Now there are mobile systems available, such as handheld units that are battery operated or can be plugged into a standard wall outlet. Now refinishers can see the benefit of having their service time reduced by 2/3 by incorporating a UV system into their refinish needs. Where does UV plays the best role? As a primer putty and clear coat. Products such as EBECRYL 8501 offer high filler content, excellent adhesion to SMC, to steel, and if prepped right, TPO without having to use a chlorinated polyolefin adhesion promoter. These materials typically cure in less than 5 minutes and can be sanded immediately after cure. For a clear coat, only time will tell. Remember, UV systems have a negative stigmatism around weathability. EBECRYL 4513 and 4680 can be formulated into a system that meets many of the performance criteria as conventional clear coats, offering excellent scratch resistance and weathability. In conclusion, UV technology is well poised to meet the newer and tougher OEM specifications. UV offers a number of different solutions that are solvent-borne UV, 100% solids UV, and even water-based UV that offers performance that meets the tougher and newer OEM regulations. UV coatings' intrinsic polymer behavior makes them ideal for improving scratch resistance and chemical resistance of coatings used in automotive. allnex sees itself as a valuable partner and strives to continuously expand its portfolio in knowledge and innovation through listening and responding to the needs of the customer and the market. Thank you for watching. Please feel free to contact me at the phone number below or via email. Thank you again for your participation.